In lesson 10.3, they throw a bunch of properties at you dealing with logarithms. So as you're trying these problems, it would be a good idea to have your notes from the day in front of you. Some of the early problems, like 14 and 16, are simply trying to get you to use some of those properties. For example, they tell us that log base 5 of 2 is one thing, and log base 5 of 3 is something else. Now in 14, we're trying to find out what log base 5 of 8 is. Well, how is that related? Well, there must be some way of writing 8 using either the 2 or the 3 from above. And there is. Log base 5 of 8 I can write as log. I can write it as log base 5 of 2 cubed. Because 2 cubed gives me 8. How does that help me? Well, again, if you're looking at your properties, there's one that says I can move any power, so that 3, to the front of the logarithm. 3 times log base 5 of 2. Now that's helpful because I know what log base 5 of 2 is. In the original directions, they tell me that it's 0.4307. So I can take 3 times 0.4307 and get my solution, which turns out to be 1.29. 16 is something similar. I have log base 5 of 3 halves. There must be some way of rewriting 3 halves dealing with log base 2 and log base 3. We have a property that says if you're taking the log of something that you're dividing, you can write it as 2 separate logs using subtraction. So I can say log base 5 of 3 minus log base 5 of 2. Why is that helpful again? Well, we know what those values are. Log base 5 of 3 is 0.6826. Log base 5 of 2 is 0.4307. So when I subtract those two, I'll have my solution. And that turns out to be 0.25. Now, still using the properties, so make sure they're in front of you somewhere. We're going to start solving for variables. In 22, I have log base 4 of 8 plus log base 4 of 9 equals log base 4 of 27. Be careful. We can't start crossing off logarithms. The only way you can do that is if you have log of one thing on the left side and one log of something on the right side. We're not quite there yet. However, using the properties, I can combine the left side into log base 4 of 9a. Right? Because if you add logs with the same base, you can combine it using multiplication. On the right side, you then have log base 4 of 27. Only when you have one log on the left and one log on the right, the bases are the same, can you drop the logarithms, which gives you an easier equation. 9a equals 27, divide by 9, so a is equal to 3. 26 follows the same idea, but there's more stuff going on. There are numbers in front of the logarithms. I'd like to get it to the point where there's one log on the left and one log on the right. So the first thing I'm going to take care of are those numbers in front of the logs. I can move them to powers. So that gives me log base 10 of 6 squared minus log base 10 of 27 to the 1/3 is log base 10 of x. Simplifying it further, just taking care of the powers, gives me log base 10 of 36 minus log base 10, 27 to the 1/3 would be 3, equals log base 10 of x. If you have two logs that you're subtracting, take a look again at your notes. That means you can write it as division. So log base 10 of 36 over 3 is equal to log base 10 of x. And finally, we have log of one thing on the left, log of one thing on the right. The bases are the same, so we can drop the logs. 36 divided by 3 is 12, So you get that x is 12. Last but not least, number 30. Log base 2 of y plus 2 minus log base 2 of y minus 2. We can combine those two using division. Which gives me log base 2 of y plus 2 over y minus 2. Now we have a problem. There's not one log on the left and one log on the right. There's no logs on the right. How do I take care of that? Switch the forms. If you're trapped inside of a logarithm, write it as an exponential. So I'll take 2, the base of the log, 1 will be the power, equals y plus 2 over y minus 2. We'll then multiply both sides by y minus 2, because you can't solve for something if it's a denominator. And we're left with an equation that we can solve. I'll distribute the 2. I'll get the numbers on one side and the variables on the other. I'll subtract the y and add the 4. And I'm left with a solution of y is equal to 6.